Unit 2A, and here we're going to do 2A1 Quadratics. This is going to be a review going all the way back to Algebra 1 before we get into the polynomials, which this unit is all about, messing around with polynomials. So reviewing quadratics real quick, we have standard form where it's ax squared plus bx plus c. And this is very useful because it gives us a y-intercept and it tells us some basic characteristics of the quadratic, how it opens and things like that. But to make it more useful, we want to turn it into what is called the vertex form. And you've seen this before, not just in quadratics, but other things, especially when we do transformations. So this vertex is very handy, h and k, and it also gives us our axis of symmetry, makes it easier for graphing, and again, transformations. So what we're going to do, we're going to take a look at a couple examples, and we're going to do just that. We're going to turn it into vertex form. So again, this standard is useful, especially when it gives us the y-intercept right here. So 1, 2, 3, 4, 5, and this is 0, 5 right here. Okay. But other than that, we need to get it in a vertex form. There's a couple ways to do this, and I do have videos in my geometry that go over turning this into the vertex form and completing the square as well. So we got plus 2x plus 5. All right, and the first thing we're going to do is we're going to take this right here and complete the square. If you remember, you're going to take your b term, divide by 2, and square it. And we're going to add that to complete the square. Well, let me go ahead and write that in and see what happens to our equal sign. And I'm going to do plus 1, all right? And here's our plus 5 over here. So I have this. That's my perfect square trinomial. Well, I just added 1 to this side, but I didn't add 1 to this side. Well, we want to leave the y alone, or f of x. So if I'm going to add 1 here, I'm going to have to subtract out another 1. So I got to take that out and cancel those two 1s, basically. So I'm going to go ahead and factor this. Again, we did completing the square for a reason. That's going to be parentheses. There we go. And that's plus 5 minus 1 is going to be plus 4. And this is my vertex right here, negative 1, 4, and x is equal to negative 1. I pre-filled some stuff in, including my little vertex line. So let me go ahead and drag that over. Come on, there we go. And I am now going to graph this at negative 1, 4. 1, 2, 3, 4. I'm going to reflect that across. And I have a very standard, non-squished parabola. And if I wanted to be a little bit more accurate, I would probably do f of 1 right there and reflect that across. But I'm just looking for the basic sketch. Okay. Let's go ahead and take a look at our next example. So this one is going to be quite a bit different in that we have y is equal to 2x squared plus 8x plus 7. And I got a y-intercept of 7. 1, 2, 3, 4, 5, 6, 7. All right. I should have put that one in before. And I'm going to complete the square. I got a bit of a problem. I'm going to factor out a 2 because when you complete the square, it's always desirable to have a is equal to 1. So let's go ahead and do that. I'm going to factor out the 2. I got x squared plus 4x, and over here is my plus 7. Then I'm going to take this and do the 4 over 2 squared. That gives me a plus 4. So I'm going to have y is equal to 2 times x squared plus 4x. And here comes the plus 4. And what did we do? Did we add 4 to this side but not 4 to this side? We added 8 because 2 times 4 is 8. We added a plus 8. Let's get rid of that 8 by subtracting 8. So I'm going to have to subtract 8. Okay? So that cancels each other out. The equal sign stays intact. So I have y is equal to 2 times, I'm going to go ahead and finish the square here, factor it basically, and it looks like I got a minus 1. All right, so my vertex is going to be negative 2, negative 1. And I can plot that. Negative 2, negative 1, right there. Okay. My axis of symmetry is going to be x is equal to negative 2. So let me drag that over. Right there. And I can reflect this point across. It's right here. And I probably want to go ahead and do, let's say, f of negative 1. Okay. So I'm going to put in f of negative 1. That's going to be, I could plug it in right here. Okay, that's going to be 2 minus 8 plus 7. Looks like it turns out to be a positive 1. Okay, so f of negative 1 is going to be a positive 1. Okay, negative 1, 1. Reflect that, and I have an idea of how my graph is going to look like. There we go. Okay, I'll go ahead and get this posted and crash and burn on that one. All right, I'm going to go ahead and get this posted. All righty, next video soon.